Hello, my name is Doug and welcome to the Principia YouTube channel. Today I'll be showing you an example on how to use the kinematic equations to help solve projectile motion problems. First of all, what is projectile motion? Projectile motion is the type of motion that objects thrown experience and are affected by gravity over time. You'll notice that for each equation listed in the table, that we don't use all the variables in one equation, but rather show the relationships between certain variables that we know so we can solve for variables that we don't. Let's look at a problem together. A toy rocket is launched from the ground at a rate of 5 meters per second. The vertical velocity is measured to be 4 meters per second, and the horizontal velocity is measured to be 3 meters per second. Given the following situation, we need to figure out how long is the object in the air for and how far does the object go. So first of all, do I need both the vertical and horizontal components for this problem? Well, only the vertical component affects how long the object is in the air for. So we're going to write down what we know in that the initial height in this case will be 0 because it starts on the ground. The final height will be 0, I should say 0 meters, always use units. The initial velocity will be 4 meters per second. And the acceleration will be negative 10 meters per second squared. The reason why it's negative is because it's pointing downward. We're going to use the second equation here, in which it goes final height minus initial height is equal to initial velocity times time plus 1/2 acceleration times time squared. So 0 minus 0 is 0, but we have 4t minus 5t squared. So 5t squared is equal to 4t. Now, because the rocket starts on the ground, we know that t equals 0 is a solution. So I can divide both sides by t, so I'm left with 5t is equal to 4, or t is equal to 4 over 5, which translates to 0.8 seconds. How far does the object go? So in this particular case, we want to actually use the horizontal velocity, and you can imagine why we do that, because if you threw your pencil straight up into the air, does it go forward at all? Well, no. It needs some horizontal component in order to actually move forward or backward. So instead of height, we're going to use distance. So the initial distance will be 0 meters. The final distance is what we're going to solve for. We know that the initial velocity in this case is 3 meters per second. We know the time from part A is 0.8 seconds. And in this particular case, or in most cases, the acceleration will be 0 meters per second squared. Gravity won't affect the horizontal component because gravity just points straight down. So the kinematic equation will look like this. Final distance minus initial distance is equal to initial velocity times time plus 1/2 acceleration times time squared. So we have final distance minus 0 is equal to 3 times 0.8 plus 1/2 0 times 0.8 squared. Now what's helpful for doing the math is that this is just going to be 0, because anything times 0 will be 0. So we have final distance is just equal to 2.4 meters. All right, your turn. Here's another projectile motion problem. This time, the toy rocket has a velocity of 17 meters per second, in which the vertical velocity is 15 meters per second, and the horizontal is 8 meters per second. Pause the video and see if you can solve this on your own. All right, ready to go? So, how long is the object in the air for? Well, the initial height is the same as the final height, which is 0 meters. We know that the initial velocity is 15 meters per second, And we know the acceleration is going to be negative 10 meters per second squared. So final height minus initial height is equal to initial velocity times time plus 1/2 acceleration times time squared. Or in this case, we have 0 is equal to 15t minus 5t squared. So 5t squared is equal to 15t. Again, we know that t being 0 is a solution because it starts on the ground. So I'm going to divide both sides by 5t, and I'm left with t is equal to 3 seconds. All right, so how far does the object go? Well, we're going to use the horizontal component, and we have that the initial distance is 0. Solving for the final distance, we know the initial velocity in this case is 8 meters per second. We know the acceleration from before is 0 meters per second squared, and we have the time being 3 seconds. So we have the final distance minus the initial distance is equal to initial velocity times time plus 1/2 acceleration times time squared. So we have the final distance is equal to 8 times 3 plus 1/2 0 times 3 squared. Because we have a 0 here, this whole expression here becomes 0. So we're left with just 8 times 3, which is 24 meters. How did you do? Feel free to look back at our sample problem if you need to, and thanks for watching.